The date is May 8th, 1654. The location, the city of Regensburg in the Holy Roman Empire. The audience included several nobles and notables, including the Emperor, Ferdinand III himself, and the man of the hour, Otto, mayor of Magdeburg, who is ready to put on a show. This was no mere science experiment to impress and dazzle. This was a political stunt. The town of Magdeburg had been ravaged just 2 decades before, losing over 20,000 people during one of the worst atrocities of the 30 Years' War, which, for those of you not steeped in European history, was a conflict initially about whether Central Europe should be Protestant or Catholic, with the answer to be decided by, slaughtering each other. But Magdeburg was making a comeback thanks to the able leadership of Otto, and he wanted to show the emperor just how far they'd come. Otto, it so happens, was more than a local politician. He was an avid scientist and inventor, and he had devised a device that many, if not everybody, before him in European history had considered outright impossible. The device was a vacuum pump. And Otto's showy demonstration didn't just convince the German elite that Magdeburg was back, baby, but it showed the scientific and philosophical world that the vacuum was real. The debate about the nature of the vacuum stretches back into antiquity and probably before that, but we don't know about it because past a certain point we don't have any written records of anybody's thoughts, either because A, those records didn't survive to the present era, or B, they didn't write them down in the first place. Anyway, my point here is that the discussion of the nature of the vacuum has a long, storied, world-spanning history. And we're only going to examine a small slice of that history in today's episode, especially the parts that intersect with modern scientific thinking. The reason that talking about the vacuum has such a long storied history is because talking about the vacuum means we're going to be skirting around the edges of a very squiggly concept.
I need a new dust filter for my Hoover Max Extract Pressure Pro Model 60. Can you help me with that?
The concept of nothingness, and whether that's a thing in and of itself, the same way that a chair or a baby is a thing. Personally, these are some of my favorite concepts to wrestle with, ideas and concepts that seem large and mysterious and nebulous, and we can poke at them or prod at them from different directions and come to very reasonable but very different conclusions and then spend our free time arguing about it. But it's also challenging to navigate concepts like this, like trying to hold Jell-O in your hand. As soon as you start to get a good grip on it, it just slips, and you have to scramble to put it back together. This is fun because it gives us an excuse, a doorway to ask some bigger questions and hopefully arrive at some bigger answers. And I hope in this episode you get a taste for the surprising complexity of a question like this, because the answer or answers aren't at all obvious, and they depend on how you approach the fundamental question. I need to mention this because today's question is whether space is really empty, which seems on the surface to be a very simple and straightforward question. You go out in space and is it empty or not? But to answer that question, we have to crack open the world of philosophy to make sure we perfectly understand what exactly we're talking about. For example, let's tackle the word empty, emptiness, void, vacuum. For a long time, philosophers, scientists, mathematicians, theologians, which all lump under the general term of thinkers, spent a lot of time wondering and worrying about whether nothingness was the same as the vacuum. It's one thing to ask about the vacuum, like can I create a region in the universe where there is no matter, where there's no stuff? Is that the same as there being nothing there? Think about it for a second. These thinkers worried about this question about whether the vacuum was identical to the concept of nothingness, because that informed the question of whether a vacuum could exist and vice versa. If you decide philosophically that nothing can't exist, that there's no such thing as nothing, there's always something, whatever that means, then a vacuum can't exist. You can't have a region in the universe completely devoid of anything. And the same goes for the other direction. If you decide that it is possible to take a region and evacuate it and remove all the stuff, and that it's perfectly possible, well, that will inform your philosophical argument about whether nothingness can exist. And so to ask the question, is space really empty? We're asking if a perfect vacuum can exist. Can we really remove everything from a region of space? Thinkers from time immemorial equated the concept of a perfect vacuum with the concept of nothingness itself. That if it is possible to create a region where you remove everything, then nothing remains. And nothingness is possible. But is nothingness impossible? Can nothing exist as its own separate entity?
So how can I have some more of nothing?
As someone who specializes in studying cosmic voids, the vast empty expanses that dominate the volume of the universe, I think about this a lot. Is nothing only defined by its boundaries, its shape? Does it have qualities of its own? Does that make it a thing in its own right? And if it does, is nothing really a thing? And so therefore nothing can't exist because, if I evacuate a region, well, then I just have a hole in matter, and like a hole is its own thing. And therefore it's not nothing. It sounds like I'm talking in circles. But I want you to take a moment to appreciate the philosophy of this. And yes, I will never tire of reminding us that science is not divorced from philosophy. It's a branch. It's an extension of it. The way we do science is informed and guided by philosophy. We have to start with an answer to these kinds of questions to proceed in our scientific exploration of the universe. And we're going to see this come to fruition with Otto and his vacuum pump. Because these kinds of questions are not mere word games. These are diving into the fundamental nature of reality, of the universe that we find ourselves in, and our ability to grapple with it. And so we go back to Plato talking about the concept of nothingness and saying, no, of course, nothing can't exist, or that there can't be a region of total nothingness, because for something to exist, it has properties and qualities that we can describe. Carrots, justice, sadness. Like, these are things that exist because we can talk about it. Nothing is the antithesis of things, so much so that we can't even define it. I can define a carrot. I can define justice. I can't even define nothingness. If I just say, well, it's where when you take away all the things, but that's just defined in terms of the opposite. We can't even talk about it. Therefore, nothingness doesn't exist. There's always something. Other philosophers shot back at this idea. They were called the atomists. Technically, their tradition preceded Plato, but then overlapped. It gets complicated. But they didn't just argue that nothing or the vacuum could exist, but that the vacuum was one of only two types of things that existed at all in the universe. You had things, called the atoms, that moved around and rearranged themselves and existed within the void, within the vacuum, within the nothing between them. Plato's student Aristotle took this battle one step further and used arguments against the existence of the vacuum to argue that nothingness can't exist. And this is where we get the origins of the famous phrase, nature abhors a vacuum. Nature hates a vacuum. Here's Aristotle taking a naturalistic approach to argue against the existence of a vacuum, and therefore against the existence of nothingness. That there really is no such thing as nothing. No matter what, there's always something. Aristotle argued, like, if you were to try to create a vacuum, say you have a plate on a table and you lift the plate up really, really quickly, there's not a vacuum underneath it because stuff just rushes in to fill the gaps instantly. So vacuums can't exist in nature. Therefore, the universe is always filled with stuff. And there's no such thing as nothing. Aristotle was mildly influential on European thought. And so we're going centuries, millennia, with leading European thinkers believing that nothingness can't exist, and therefore the vacuum can't exist. And you can run this argument in the other way. Vacuums can't exist, therefore nothingness can't exist. There's always something in the universe. I will acknowledge there is an entire Middle Eastern, Indian, and Chinese philosophical traditions that grapple also with the nature of nothingness. And those concepts have worked their way into modern scientific thought. I'm just not following those threads today. Those are very interesting and very powerful philosophical thoughts and traditions. feel free to ask, because it gets really cool. I'd love to do an episode on that. But in European circles, most everybody agreed nothingness can't exist. There's always something in the universe, and therefore vacuums can't exist. And then comes Otto. There had been interest for centuries in trying to develop a vacuum pump, or rather a device that could potentially create a vacuum if vacuums did indeed exist. This is where we see like pre-scientific thinking. No one's just taking Aristotle's word for it. They're wondering, they're like, man, maybe I can make a device that like sucks out all the air and leaves a void, and I can prove the existence of the vacuum. That'll stick it to old Aristotle, right? No one could quite do it until Otto. And this was what he showed off to his emperor. He took two hemispheres, pressed them up against each other, sealed the boundary with sealant. I suppose he didn't have super glue, but the equivalent. And then he used his newly developed vacuum pump to pull the air out. And then these two hemispheres were sealed together. And then to really show off, he got like teams of horses tied up to either hemisphere, and they tried to pull it apart. And even horses, like the most powerful thing in the world at that time, couldn't even pull these two hemispheres apart. Thanks to a lot of work, scientific and philosophical work, he knew the reason why we couldn't pull these hemispheres apart. Even horses couldn't pull the hemispheres apart. It was because there was a vacuum inside, there was nothing, and then there was all this air pressure sitting on the outside that was pressing in on the hemispheres. And even the strongest horses couldn't overwhelm that air pressure. That's pretty impressive. That's pretty showy. I suppose it worked. And he had a good reception, and he did the impossible. He sucked out all the air, and there was apparently a vacuum inside, which implied that there was nothing inside the hemispheres. Remember, for thousands of years, Europeans had believed that nothingness couldn't exist, that there was no such thing as nothing. Yes, we could talk about it in the abstract, but in the actual physical concrete universe, there was always something, and therefore vacuums couldn't exist. And here's Otto, the mayor, apparently making a vacuum. This leads to some big questions, as you might imagine. Like, was it truly empty inside those spheres? They tap on one side and they couldn't hear it on the other, except what would reverberate around the shell itself. So whatever was inside, it didn't transmit sound. Whatever it was on the inside was lighter than the air, but was it a true vacuum? Was it truly empty? Was it truly nothing? Or was it just less air than before? Or was it something else? This became a huge debate. Otto clearly demonstrated that something like the vacuum was possible, at least artificially. Okay, there's something going on inside these spheres. And yeah, there's the colloquial definition of a vacuum, like just less air pressure than on the outside. But was it true? Was it a real vacuum? Was it true nothingness? Were those spheres empty on the inside? And what did that imply? Or was it filled with something else? We didn't know. We were barely figuring out at this time what air was in the first place. What did all this mean? Thinkers of all stripes would wrestle with these questions. Keep in mind, this is all happening centuries before the discovery of the atom, so we're not even sure here what the fundamental constituents of matter are. There's a lot of splitting, a lot of debate. There's no serious consensus in philosophical and scientific circles moving forward from Otto's demonstration. But the general consensus is that, okay, maybe vacuums can be created artificially, but they probably don't exist naturally. We have to work really hard with vacuum pumps to create a vacuum, and then but they don't happen. Nature just doesn't do it automatically. And yeah, Aristotle's been proven wrong. Vacuums are possible, but that's just air. That's just air. Maybe there's another substance inside of the spheres. Maybe there's a substance that imbues all of the universe. We'll call it the ether. That sounds pretty cool. Ether is this. It's hard to describe because, as the centuries went on, the thinking of what the ether might be and what its properties might be changed as we learn more and more about the universe. One of the biggest arguments for the existence of the ether was the discovery of electromagnetic radiation. Light. That light is waves of electricity and magnetism. And it's very natural to say, okay, waves of electricity and magnetism, what is it waving? Like if I look at ocean waves, I see the waves, and these are waves of water. I hear sound waves, and what are these? These are pressure waves in air. Well, what are electromagnetic waves? What are they waving? What's the medium? How do they travel from one thing to another? It's a solid argument. It's a good argument to make that say, okay, waves need something to exist in order for them to propagate from point A to point B. So there'll be this substance that suffuses the entire universe, and I'll call it the ether, also known as the luminiferous ether if you're feeling fancy, like at a cocktail party or something. But when you're just in your PJs, it's just ether. So scientists believe, many scientists, if not all scientists, at one point believed that the universe was not filled with vacuum, that when Otto, and then people after Otto also did this, created a vacuum, yes, it was evacuated of air. There's no more air in the hemispheres, but there was still ether. There's still something. Or when I'm watching the planets move and they're orbiting around the sun, they're not swimming through nothingness. That doesn't even make sense. They're swimming through the ether, this substance that has all the right properties we need for it to be pretty much undetectable, but still exist. This idea did make sense until the late 1800s, until two experimenters, Albert Michelson and Edward Morley, out in Cleveland, Ohio, of all places, found no evidence for the ether.
With the exception of Cleveland.
The experiment, I'd love to do an entire episode just on the Michelson-Morley experiment. Just feel free to ask about how groundbreaking it was. But the basic gist is this. If light is moving through the ether is the substance out in space. Everywhere you look, everywhere you walk, there's a little bit of ether there. You go out in the middle of nowhere between the planets, and basically all you got is ether, and this is what light is waving. As we swim through the ether in our orbit, as we're orbiting the sun, sometimes we're going in one direction through the ether, and then sometimes we're going in the other direction. So if light is moving through the ether, then when we're going in one direction, we should see light speed up a little bit, and when we're going the other direction, we should see it slow down a little bit. Instead, they found that light, no matter what, was always moving at the same speed. Later, Einstein would incorporate this idea into special relativity, that the speed of light is always a constant, and we don't need an ether anymore. Light just moves. It can move through a vacuum. You can have nothing, and light, electricity, and magnetism will propagate. They'll self-propagate. They don't need a medium. It's not like sound waves. It's not like water waves. It's their own kind of waves. Just leave them alone. When the planets are orbiting the sun, they're not plowing through an ocean of ether. They're just moving through vacuum. Okay, so the vacuum is possible, thanks Otto. There's probably no ether. We see no evidence for its existence, thanks Michelson and Morley. So is space really empty? Well, I suppose it depends on what you mean by empty. It's certainly less dense out there. If I go 100 miles up, there's a lot less air than there is down here, but there's still kind of air. Not enough to breathe, but it's still around. That's not really empty. If I go out into the middle of interplanetary space, it's way denser. It would register as a vacuum here on Earth in our most precise laboratory experiments, but it's not really a vacuum. There are, like the solar wind, the electrons streaming off of the surface of the sun, totally filling the solar system. Yeah, it's low density, but we can measure it. We measure it all the time. That's not really empty. If I go out past the boundaries of the solar system, oh gosh, it's not empty there either. There's the interstellar medium. There's this mixture of particles and dust, ejected from other stars and from supernova. They're just floating around. And yes, it's incredibly low density, but it's not nothing. We can measure it. The Voyager probe's literally measuring it right now. That's not empty. What if I go out into, intergalactic space? If I go the spaces between the galaxies? Well, no, there's the warm, hot intergalactic medium. There are cosmic rays passing by. And of course there's dark matter, right? Like dark matter is matter. It's a thing. Just because it's invisible, it doesn't mean it's not a thing. Dark matter exists. If I sit in between the galaxies, I'm in a sea and ocean of dark matter constantly streaming through me. That's not empty. What if I go deeper into the universe, to a place totally devoid of matter? I can go into the deepest voids. The largest voids are hundreds of millions of light years on a side. You can go into their deepest regions. The nearest galaxy is tens of millions of light years away from you. There are no stars. You're too far away for, stray hydrogen atoms to be floating by. Cosmic rays don't even really reach you. Where you could draw a box around you, like an imaginary box, like, I don't know, a light year on a side. And there's nothing. There's not even dark matter. There are no hydrogen atoms, no cosmic rays, no dark matter. Is that empty? Well, not quite. Because there's the CMB, the cosmic microwave background. The light left over from when our universe transitioned from a plasma state when it was 380,000 years old. This is the light echo, the fossil remnant of the Big Bang itself. Something like 99.999 whatever 99% of all photons in the universe belong to the CMB. It's the single brightest thing in the universe. You just can't see it because it's in the microwave, but it's there. And since the CMB was created everywhere in the universe, it completely soaks the universe. So even in the deepest void, you're going to be bombarded with CMB photons. You think you're alone, you think it's empty, and then you put on your microwave goggles, and then all of a sudden you're seeing the CMB light. You're not alone. There's neutrinos too. There's neutrinos left over from the Big Bang too. Those are harder to see. But they're there. They're passing through you. That's not nothing. Maybe Aristotle was right. We can create partial vacuums. Everyone grudgingly acknowledged that after Otto's experiment. And the ether doesn't exist. Everyone grudgingly acknowledged that after Michelson and Morley's experiment. But maybe these are all just partial vacuums. Wherever you go in the universe, there's always something. Even not if there's not a lot of it. What about that old atomist idea from, a couple thousand years ago? What if we don't count the things, but the spaces between the things? Is that a true vacuum? Imagine you're sitting in the middle of the deepest cosmic void, with the nearest galaxy, 100 million light years away from you. There are no hydrogen atoms. There are no cosmic rays. There's no dark matter. The only thing you detect is the occasional ping of a neutrino or a cosmic microwave background photon. But those still take time to reach you, right? Or let's say you make a box around you and you're able to block them. Yes, I know the box itself would start emitting photons. Okay, just roll with me with this thought experiment. What about the space between the stuff? Like if I am able to reduce it so that only one photon hits me every minute, I don't know, that's how lonely I am in the universe. So, bing, a photon hits me. A minute later, bing, another photon hits me. What about that space in between? What about those gaps? Am I truly and completely and utterly and frighteningly alone? What about that? Is this the true vacuum of the universe? Is this true nothingness? Is space really empty? Well, we haven't yet introduced the quantum elephant sitting in the corner of the room. And that's vacuum energy. Quantum mechanics, and especially quantum field theory, tells us that the particles we identify with everyday life, electrons, photons, the top quark, that each of these are associated with a field that soaks all of space and time. And when regions of these fields energize, excite themselves, we see them as a particle. But even when the particles aren't there, the field still exists. And the field, in its ground state, in its ignoring everybody, nobody bothering it not bothering anybody else state, the vacuum fields have energy associated with them. And it's not zero. Another way to view this is through the Heisenberg uncertainty principle. If you're not looking, the vacuum of spacetime is constantly roiling with particles that pop in and out of existence. It's allowed by just the fundamental quantum nature of uncertainty. That's another completely compatible way of looking at this. That the vacuum of the universe has energy. Now, last time I checked, energy is a thing. It can affect me. I can measure it. I can affect it. That counts as thingness, right? So even though I'm in this box, in the deepest void, and I've removed all the particles and the radiation and the everything, and I'm counting the time between the CMB photons, I still have the vacuum of the universe. And remember, ancient people equated the vacuum with nothingness. That they said, if there's a vacuum, then there is truly nothing. But here we see a vacuum, no matter, there's no stuff, but there's still energy associated with that vacuum, and that is most definitely a thing. And so the vacuum of the universe isn't truly empty. I'm not alone. So no, the spaces in between all the stuff is not void, it's full of something, it's full of vacuum energy. Both Plato and Aristotle and the atomists and everybody were kind of right and also kind of wrong, which is kind of how it works. Because there's vacuum energy. Space is not empty. But let's keep going in this thought experiment. What if we were to remove the vacuum energy? What if we devised some device, some machine to negate the vacuum energy? I know it's not possible, but just run with me here. Okay, it'll be fun, I think. We're going to negate the vacuum energy. There's a fundamental energy to space and time due to quantum fields. Technically, that energy is infinite, but we're not going to talk about that part. We're going to negate it. We're going to make it zero. We're going to make it go away. Have we done it? Have we made space truly empty? Is this it? Have we achieved the old atomist dream and finally defeated the tyranny of Aristotle? If we move to the deepest voids, shield ourselves from the CMB and from neutrinos, and we negate the vacuum energy, have we created a pure vacuum? Have we achieved true nothingness? Have we constructed nothing in our universe as its own and separate entity? If you've glanced at the runtime remaining in this episode, you've probably guessed that there's more to the story. And there's a reason that I front-loaded the episode with a bunch of philosophical musings about the nature of nothingness. When we go back and forth, is nothing its own kind of thing, or can it only be described in relation to things, and therefore does it truly exist? So I did that because I'm about to present a more subtle point that I think you'll appreciate, because by now we're very sophisticated when it comes to the concept of nothingness. We're going to talk about space itself. The question that I'm trying to answer today is space really empty? And so far we've been tackling the empty side of the question. We've been removing more and more things: air, ether, particles, radiation, vacuum energy. We've been focusing on the emptiness, but here's a question back to you. What do you mean by space? When you say, is space really empty, what is space? Again, could you define that for me? You say, well, Paul, of course, I mean outer space. Don't be weird. But let me challenge you with this. Do you mean outer space? When you say outer space, when you just casually toss like, hey, outer space, what are you really saying? Okay, let's dig into that. Outer space is the opposite of inner space. Inner space is presumably the Earth, the atmosphere, the stuff close to us. That's inner space, and then outer space is everything else. But inner space and outer space are just two different kinds of space, right? So if we want to ask if outer space is empty, we have to decide what we mean by space. What is this word that we are using? And why are we using it in this way? This is why I always love to dig into the philosophy that power scientific inquiry, because as we're casually discussing the nature of the vacuum in outer space, wait a minute, we're actually resting on a mountain of philosophical ideas into the nature of space itself and what we mean by that word. Let me explain. I need to rewind the clock a bit and introduce a man by the name of René Descartes, an absolute genius of a human being living in the early 1600s who is not talked about nearly enough on the show, mostly because of Patreon, patreon.com/PMSutter. If you want to hear more about Descartes, you need to contribute more. And if you don't want to hear more about Descartes, maybe contribute anyway. I truly appreciate all contributions. That's patreon.com/PMSutter. Descartes' ideas are so fundamental and essential to modern scientific thinking that they sit almost too far in the background. Essentially, for almost every topic we talk about on the show, I would need to spend the first 30 minutes discussing how Descartes laid the groundwork for our modern understanding. But today is not most days, and today I get to talk about Descartes, and that's a good day indeed. Descartes had two major ideas. Well, he had like 5,000 major ideas, but two
I'm especially psyched out of my mind about.
His first idea is the very concept of space itself. Before Descartes, we had geometry, we had algebra, we had the mathematics, and we were understanding, structures and objects, and we did this. But Descartes introduced a mathematical language to describe placement and relationships and extent. He didn't invent geometry, but he gave us a way to mathematically encapsulate the extent of objects and their relative placements to each other in the universe. I'm sure you've drawn a little XY axis or seen a plot showing XY coordinates. Those are called Cartesian coordinates, as in Descartesian coordinates. And it's not like he was just like, I know if I draw these two perpendicular lines, I can torture future math students for eternity. No. He introduced a concept where I can mathematically describe the relative positions of objects and their extent, their relationships to each other. He gave us the mathematical concept of space itself. Of course, we as humans exist in a three-dimensional world, and we think of things three-dimensionally, and like yes, we take that for granted. Descartes gave us a mathematical structure for describing that and using that. Descartes' second big idea was the ultimate expression of Aristotle's argument that nature abhors a vacuum. He argued that space and matter were the same thing. Check this out. If you look at something, it has physical extent. It has length and breadth and depth. That's how we understand volume. That's how we understand space. It's through the spatial extent of objects that we have our conception of space and orientation and placement. Without any stuff, we wouldn't have space. Therefore, the vacuum doesn't exist because space itself arises from the presence of matter. If you have stuff, that is how you get spatial extent. That is how we have a manifestation of our universe. That is how our universe exists, is through the expanse of objects. And so therefore, there is no such thing as the vacuum, because if you were to get rid of all the stuff, there wouldn't be any space. There wouldn't be placement. There wouldn't be relative position, which is what our universe is. Now, that's a pretty solid argument. It was also pretty solidly rejected by Otto's experiments, but his ideas about the nature of space would remain. And one of the biggest fans of his work was none other than Isaac Newton, whose philosophical musings have not gotten the praise they deserve. We tend to focus on his physics, but his physics insights flowed from his philosophical answers to the very philosophical questions into the nature of the vacuum. Newton would be the man to give us the fundamental concept of space that we are all working with. And that's because Newton took a very a la carte approach to Descartes' work. He would take Descartes' idea of space, but reject the idea that vacuums cannot exist. And what he did was he thought of motion. He examined the very concept of motion. When you say, what is motion? Can you define what motion is? And can you wrap it in mathematics so that I can do physics and make predictions? He would say, oh, motion is objects changing their position in space. And I know that sounds obvious. It sounds obvious because we've had 3 centuries to get used to the idea. And we've had 3 centuries to use this idea. Oh, objects changing their position in space gives me a mathematical foundation to do this thing that I call physics. Newton says that space exists, it's a stage, and we are actors acting on that stage. We move across the stage, we hit our marks, we say our lines, but the stage is there. The stage is a thing. It has its own identity in the universe. And this is the foundations of modern mechanics. People simply didn't view the universe the same way prior to Newton's insight and Descartes' insight. Yes, they knew about motion and placement, I'm over here, you're over there, I'm going to go over there. But now we're thinking about it in a different way. We're thinking that there exists space underneath us and that we are moving on top of that. We are changing our positions, and we can capture this mathematically with coordinates and velocities and positions and vectors and all the machinery that makes physics work. Descartes introduced space as this mathematical abstract to help us quantify the extent of material existence, and it proved to be an extremely useful and powerful tool, so much so that we force middle schoolers and high schoolers to learn it, because we think it's kind of important. And it's so important that Newton elevated the concept of space to be the stage on which we act our parts. And then Einstein took it one step further with general relativity. Einstein said this stage doesn't just sit there in the background or on the floor for us to act on top of. The stage takes part in the play. Space and time are flexible. They change and respond to the presence of matter and energy, and then the curvature of space and time dictate how matter and energy are to move. Space, according to Einstein, is a dynamic entity. And now we can really ask our question, finally, is space really empty? If we remove all particles, all energies, all everything, all vacuum energy, yes, we've created a vacuum, but have we created nothing? Have we created emptiness? Well, what about space? Doesn't space itself remain? Isn't that a thing? The way that particles and hangnails are things? One argument is saying, no, Paul, please. Calm down. Space, the way you're using that word, is a mathematical abstraction. It's a way for us to deal, to measure the force of gravity or measure things, but it doesn't have fundamental existence of its own the same way you and me do. It's just a mathematical concept. And if I go out in the middle of nowhere in the deepest voids, I am truly alone. There's no such thing as space. I'm truly empty. I've created nothingness. Let me say this. What about gravitational waves? If two black holes merge together, they emit waves of gravity that then propagate outwards. Gravitational waves do not require the presence of matter and energy in order to exist. They are undulations. They are wiggles in space and time itself that travel. They exist. If I sit out there in the middle of nowhere in my little box and you're telling me space doesn't really exist, what is this gravitational wave? If a gravitational wave passes over me, doesn't that exist? It's influencing me. I'll feel it. If it's strong enough, it'll crush me. Pretty sure that meets the definition of existing, that which can crush. Does space not? If space is just a mathematical abstraction that we don't have to care about, and it's just a mathematical tool that we use to get our homework done. It's not an entity. It's not a thing. What about these gravitational waves? It's not a mathematical abstraction that's stretching me. So now what? Well, this is the fun part. You can go out in the deepest void, away from all the regular matter, away from all the dark matter. You can build a box that prevents any CMB radiation or neutrinos from passing through. You can create some sort of device that eliminates the vacuum energy. You are completely, absolutely alone in empty space. Or are you? Is space itself real? Is space itself something? Is nothing, true nothingness, allowed to exist? There is no answer. Maybe space itself is real as you and me and cheese, in which case nature truly does abhor a vacuum and Aristotle was right all along. There is nothing truly empty out there because wherever you go, space exists. Or maybe space is just a mathematical convenience to help us do our physics homework. And that the vacuum is empty. And that nothingness is a concrete possibility. But if nothingness is a concrete possibility, then how can we define and describe that nothingness as an entity in its own right without just saying it's what's left when you take everything away? Is it allowed to be its own thing? And in that case, if it's its own thing, if nothingness is truly a thing, then how could it not exist? Is non-existence possible in our universe? Plato, Aristotle, the atomists, Descartes, Newton, Einstein, our good Mayor Otto, they all took their own crack at this question. now it's your turn. Thank you to my top Patreon contributors this month. Thank you to Carrie K on email, Michael M on Facebook, Terry B on email, Joyce S on email, and Raymond D on email for the questions that led to today's very, very twisty, fun episode. And thank you to my top Patreon contributors. Thank you to all of them, patreon.com/PMSutter. But my top ones this month are Justin G, Chris L, Barbara K, Alberto M, Duncan M, Corey D, Nyla, John S, Joshua, Scott M, Rob H, Lewis M, John W, Alexis, Aaron J, Gilbert M, and Valerie H. That's again, patreon.com/PMSutter. Every single contribution matters and counts. And hey, if you don't want to contribute, it's cool. We're cool. There's still something between us. There's not a vacuum. Don't worry. Why don't you go out on iTunes or Spotify or whatever, wherever you get your podcasts, and leave a positive rating. It helps. That is the biggest thing to help get word out about the show. Anyway, send me more questions. This show is not yet over. It will never end. Probably not. I hope not, because I have a lot of fun doing it. So please send me questions, askaspaceman@gmail.com, or just go to the website, askaspaceman.com, and I will see you next time for more complete knowledge of time and space.
No meaning did, no hidden cause didn't come to guide and teach. Just dance beyond my fingers' reach. I let it pass through tangled thread and kiss the crown atop my head, atop my head. No metaphor, no grander tale, just air in motion, soft and pale. No question asked, no truth to buzz. I let the wind be what it was, what it was, what it was. No meaning deep, no hidden cause didn't come to guide or teach. Just dance beyond my fingers' reach. I let it pass through tangled thread and kiss the crown atop my head, atop my head. No metaphor, no grander tale, just air in motion, soft and pale. No question asked, no truth to buzz. I let the wind be what it was. No meaning deep, no hidden cause. No meaning deep, no hidden cause didn't come to guide or teach. Just dance beyond my fingers' reach. I let it pass through tangled thread and kiss the crown atop my head, atop my head. No metaphor, no grander tale, just air in motion, soft and pale. No question asked, no truth to buzz. I let the wind be what it was. No meaning deep, no hidden cause it didn't come to guide or teach. Just dance beyond my fingers' reach. I let it pass through tangled thread and kiss the crown atop my head, atop my head. No metaphor, no grander tale, just air in motion, soft and pale. No question asked, no truth to buzz. I let the wind be what it was. I let the wind be what it was. I let the wind be what it was, what it was. No metaphor, when it what it was, be what it was. What it was, what it was. No meaning deep, no hidden cause didn't come to guide or teach. Just dance beyond my fingers' reach. I let it pass through tangled thread and kiss the crown atop my head, atop my head.